When it comes to designing and building locomotives, logging railroads remain unmatched in the variety and uniqueness of their engines. This was mostly due to the unique circumstances each railroad faced, such as the geography of the land, how heavy the loads were, and how much money the line had to work with. Each railway usually came up with their own solutions, but for the bush tramways of New Zealand, the one solution they all seemed to have in common was just to add more wheels. Like many other countries in the late 19th century with a massive logging industry, New Zealand timber companies wanted a cheap and easy way to move logs. Most companies in America and Australia built tramways and temporary railways. However, the companies in New Zealand often didn't have the money to afford laying metal rails, especially if the tracks would only be temporary. As a result, many bush tramways used wooden rails in place of iron or steel ones, as not only were they significantly cheaper to build and dispose of, but could also be moved and relayed relatively easily. The biggest drawback with using wooden rails, however, was that they weren't as durable, nor could they carry the same weight as their metal counterparts. As a result, many of New Zealand's bush tramways still had to use horses or towing cables to pull wood trains along their lines, as the wooden rails couldn't support the weight of most conventional locomotives. Despite this, there was still a demand for locomotives that could work on these rails, and so several engineering companies stepped up to fill this niche. One of them being Johnston Sons. One of the locomotives they built, known as the Type A, was an 040 design weighing just 7 tons, featuring inside cylinders that drove an internal jackshaft to power its wheels. These engines were also fitted with broader wheels to allow them to run on both wooden and metal rails. 8 were built between 1896 and 1927, 4 being given tenders while the rest were simply operated as tank locomotives. Moore & Sons, who owned one of these engines, converted theirs to an 060 to help improve the engine's adhesion. Another type of engine Johnston built were the Type Bs in 1911, though these were built for use on steel rails, not wood. They were essentially pseudo-Shay locomotives, having an 0440 wheel arrangement and 2 cylinders mounted vertically on one side of the boiler driving a jackshaft connected to the engine's wheels. The boiler was even off-centered to counterbalance the weight of the cylinders, just like Shay engines. The main difference between the Type Bs and the Shays was that the jackshaft was located between the frames rather than on the outside. Only 2 of these were ever built. But the most bizarre and fascinating locomotives ever built by Johnston were their Type Ds. Certain wooden railways could only handle loads of 1 ton per axle, making it difficult to design a locomotive both light enough to run on the line and powerful enough to do the work needed of them. The Type Ds were designed to meet that demand in 1910. These engines were fitted with 16 driving wheels to help evenly disperse their 16¼ ton weight over the rails. The jackshaft that drove the wheels was set between the frames and used spur gears to transfer rotation from the shaft to the wheels. The shaft itself was powered by 2 vertical cylinders pointed downwards, mounted behind the boiler to help with weight distribution, and was also fitted to allow the engine to be geared up and down if needed. The end result looked more like a caterpillar than a conventional locomotive. Even with the additional gearing, these engines only ever managed a top speed of about 8 km an hour, and were known to quickly wear out the beveled gears that drove their wheels. Despite this, the design proved successful, with at least 16 being built between 1910 and 1927 by Johnston for use in sawmills and on wood-railed logging tramways. Johnston, however, wasn't the only company to build these caterpillar-esque engines, as in 1912, A&G Price Limited produced what was known as the Price 16-wheeler. It was essentially an identical copy of the Johnston design, with the main changes being it used different gears in its wheels and could negotiate tighter turns, but was much heavier than its counterpart. 4 of Price's 16-wheelers were built, with one working from 1912 all the way to 1951. Another similar design also came from G&D Davidson & Co. in 1916, this being known as the Heavy 12-wheeler. Unlike the previous designs, all the wheels of the engine were chain-driven as opposed to using gears and shafts, and was also relatively lightweight, allowing it to run on wooden rails, unlike the Price engines. It was also less of a copy of Johnston's design and more of an upgrade/refinement of previous engines built by Davidson's. Only 2 of these engines were ever built. For many bush tramways in New Zealand, it seemed that more wheels was simply the way to go for their engines. Obviously, these engines weren't without their flaws, only able to travel at very low speeds, requiring their gears be frequently replaced, and overall being more awkward in design compared to other contemporary geared locomotives like Shays and Climaxes. Despite this, these bizarre caterpillars, 16-wheelers, whatever you want to call them, were exactly the engines New Zealand's tramways needed. Just goes to remind us that no design is absurd if it works. Have you ever needed a steam locomotive for your railway so much that you just slapped a boiler and some cylinders onto a spare flatbed wagon, only to accidentally create one of the most versatile steam locomotives ever? Because that's what this guy did. Born in 1839, Ephraim Shay worked as a teacher, a clerk, and a civil servant before saying, "Sod this office job, I'm going to become a lumberjack." He started his own logging company around the 1860s and wanted a better way of moving his logs to the mill, as he could only use snow sleds, meaning he could only move logs in winter. He constructed a narrow-gauge tramway in 1875 to transport the trees, which allowed him to cut logs all year round. Eventually, Shay needed some sort of locomotive to run the line. As there wasn't any way he could buy engines to run on the narrow gauge rails at the time, he took a flatbed wagon that was used to carry the logs and just mounted a boiler to it. He then fitted 2 cylinders onto the boiler that would drive a set of wheels on the rear bogie of the flatbed. The driving wheels of the design underwent several changes, with chains and belts being used to power the wheels. The final design instead saw 2 cylinders mounted on the right side of the frame pointing downwards. These were connected to a drive shaft which powered the wheels with beveled gears. The drive shaft was also flexible, which allowed the bogies to articulate, meaning it could negotiate tight corners much better. Because of the positioning of the cylinders, the boiler had to be set slightly to the left in order to counterbalance the cylinder's weight, giving the overall locomotive a unique profile. After getting the design patented, the Limmer Locomotive Works of Ohio built Shay a prototype engine in 1880. The engine was well equipped for the job and could pull the timber wagons with ease. The design was later improved, with a newer Class B type being built in 1884 that was fitted with a 3rd cylinder. In 1885, a Class C type was built that had 3 cylinders and an additional set of bogies fitted to the frame, giving it more tractive effort, and a Class D was made with 4 sets of bogies. The Shay design was very successful and was used all over the United States in quarries, factories, logging railways, and even plantation work. Its ability to accelerate quickly with heavy loads and run over steep and uneven tracks meant there was very little heavy-duty work the engine couldn't do. With all of its wheels powered and with weight on all of them, the engine had a very high tractive effort, although the small wheels and the way they were driven meant the engine didn't have a very high top speed. After Shay's patent on the locomotive's design expired, the Willamette Iron and Steel Works started to build their own Shay locomotives that were essentially copies of Shay's original design. They were called Willamette locomotives for legal reasons, but most still referred to them as Shays. Other nicknames for the engines were Sidewinders or Stemwinders because of their unusual side-mounted drive shafts. Many were exported to around 30 different countries where they continue to show their usefulness, with some being sent to Australia and other such countries with booming logging businesses. While not the fastest or most elegant looking engines, the Shays were powerful for their size and served well for many years. 118 Shay locomotives have been preserved, with many still running on preserved lines. Just goes to show how far improvisation can take you. During the logging boom in the US, many companies faced the problem of transporting timber from the woods to its intended destination. Many logging companies used sleds to move timber, but these were only viable in winter when the ground was much harder. Building a railroad was an option, but would have been a lot of work and expense for something that would have become useless once all surrounding trees were cut down. Steam tractors and off-road vehicles were an emerging technology, but were unreliable, couldn't transport nearly as much as a railway, and without a solid road, they'd most likely churn up the forest floor into a muddy mess, making it impossible to traverse. So what was the solution? Build a railroad, but out of logs. Most logging railroads naturally had a plentiful supply of logs that were unmarketable, and so rather than use metal rails, they'd simply lay these useless logs in a line parallel to each other. Then an engine, usually custom built, could easily run along these rails to and from its destination. Known as pole roads, these roads allowed logging companies to move much heavier loads much faster without the risk of getting bogged down, while at the same time being very low cost to build and maintain. The rails were dirt cheap to build, requiring nothing more than setting the logs on the ground an equal distance from each other and securing them in place, either with pegs or by building up a dirt foundation around them. If the line needed extending, a few more logs could be thrown down in no time. If the line needed to go in a different direction, just picking up and relaying the logs was a breeze. And then once the company was done with the line, they could either easily pull up the logs or just leave them to rot. Locomotives were custom built to run on these makeshift rails, either in a specialist locomotive works, or more commonly, one would be slapped together on site. Unlike a regular railroad, the wheels of the rolling stock were concave as opposed to just flanged. This prevented them from slipping off of or between the logs. While this did make shunting or switching more difficult, most pole roads developed their own, albeit crude ways of switching and shunting trains. These wheels also allowed the locomotives to climb steeper gradients and handle traversing the roughly laid rails, allowing the pole roads to be much more adaptable than regular railroads. They weren't without their drawbacks though. Most engines travelling on a pole road couldn't travel very fast due to the nature of their rails. On top of this, despite being able to climb steeper gradients than a regular railroad, many pole road locomotives struggled to climb uphill while carrying a heavy load, necessitating some trains to be split up to lighten the load and a very liberal amount of sand be spread over the rails to provide more traction. Despite this, pole roads were used for a surprisingly long time, right up until the end of the US logging boom. Sure, they weren't revolutionary or the next step in development for railroads, but as a temporary cobbled together solution, they more than exceeded in practicality. Nowadays, with much better off-road vehicles and a significantly smaller demand for lumber, pole roads are pretty much obsolete, but all the same, they remain as a testament to how far a little improvised engineering can go. Logging railways around the world were dangerous and hard-going for both the men and equipment that worked on them. The poorly laid rails, tight bends, and heavy loads meant that locomotives needed to be specially designed to work on them, as normal engines would be too heavy or struggle to traverse the rails without significant modification. As a result, many logging railroads built their own slapdash locomotives to do the work, but these weren't always reliable. Then, one day, the solution to many logging railways' problems arrived in the form of a climax. In 1875, a man by the name of Charles D. Scott ran a successful logging railway in Spartansburg, Pennsylvania. Despite only having a limited education, Scott was quite mechanically gifted and had designed his own locomotive to work on the line around the mill. Despite its relatively scruffy nature, the locomotive was quite effective on the railway, leading Scott to further pursue locomotive design, believing there was a market for machines like his on logging railways all over the country. His finalised design was simple. It was essentially a vertical boiler mounted on a flatbed car with its cylinders set in the middle pointed downwards like a marine engine. The cylinders connected to a drive shaft and two-speed gearbox, which in turn connected to both sets of bogies and powered them through a series of gears. For extra traction, the boiler was mounted above the front set of bogies and the water tank was mounted over the rear. The frames of the engine were made of wood and a simple open cab was mounted over the whole arrangement. The simple design, coupled with the wooden frames, made the engine cheap to build, sell and repair. Scott approached the Climax manufacturing company with the designs, who agreed to build them, and in 1888 the first 4 locomotives were completed. Because of his limited education, Scott had sought the aid of his brother-in-law George D. Gilbert to help draw the designs of the locomotives and file the patent for it, as Gilbert had worked with steam engines before. Gilbert, however, filed the patent in his own name with no mention of Scott, causing considerable legal trouble later on. His patent, however, came with its own issues. The wheels of the engine were driven with differential gears, the idea being that wheels on one side of the axle would be able to rotate freely to help the engine negotiate tighter turns. In reality, this left half the wheels on the locomotive unpowered, which significantly reduced its tractive effort. An engineer at the Climax company, Rush S. Battles, then patented an improved design which used beveled gears to drive the wheels. Later drawings had the boiler be much bigger and mounted horizontally along with its cylinders, making it look more like a conventional steam locomotive. And once again, this patent was filed without a single mention of Scott. Scott, fed up with the disrespect, filed a lawsuit against Gilbert and Battles before submitting his own patent. Scott's new patent combined the basic design and two-speed gearbox of Gilbert's engine with the beveled gearing of Battles, but this time with casing around the gears for protection and to contain lubrication for said gears. Scott won the lawsuit and rights to the patent, but was left penniless as a result, hardly making any kind of profit from his engine. The Climax company continued to build these engines regardless, with them eventually being known as Class A types. On average, they had a tractive effort of 13,200 pounds in first gear, 6,600 in second, and a top speed of 10 miles an hour. They were capable of negotiating tight bends with ease, and their bogies were sprung, allowing them to traverse bumpy and poorly laid rails without derailing. The cabs were initially open by design, but later changed to being closed, providing crews with much better protection from the weather. They were also quite spacious, which made them popular with both engine crews and loggers, as there was more than enough room for passengers to ride in the cab on rainy days. The Class A's were easy to modify too. Many were built to different gauges, from 2 foot narrow to 9 foot broad, and their wheels could be changed out accordingly to the rails they'd be running on. Smooth, standard wheels for regular rails, grooved or cleated wheels for wooden rails, and concave wheels for pole roads. As the years went on, the design was improved. Steel frames were used in place of wood, metal cabs replaced wooden boards, and the vertical boilers were swapped for T-shaped and later regular horizontal boilers. 4 Class A's were built with an 040 wheel arrangement for use in Tionesta Valley, but no more were built after they were found to be underpowered. The popularity of the engines led to the Climax manufacturing company ceasing production of their other products and rebranding themselves the Climax Locomotive Works to focus purely on building locomotives. Despite their instant success, demand for a more powerful model grew, and so in 1893 the Class B was introduced. 2 Class Bs had been built in 1891 following Battles' original patent. The boiler was larger and horizontal, with the cylinders mounted either side of it towards the front, driving a transverse shaft which in turn powered the main drive shaft. These engines, however, were unsuccessful, as the multiple gear system present in the Class A's were very difficult to incorporate into the Class B's. As a result, the engine's gearing was overly complicated and problematic. When the new version of the Class B's were put into production in 1893, they had the complex gearing removed and their cylinders were angled 25 degrees downwards. This made them considerably more reliable, and just like the Class A's, they were a massive success. These two came in all shapes and sizes, initially using round firebox T-shaped boilers before switching to regular square fireboxes, then changing the boilers to tapered designs instead of parallel. Further improvements included strengthening the frames and changing the Stephenson valve gear to Walschaerts. In 1897, the last variant of these engines was produced in the form of the Class C. These were essentially the same as the Class B, but with an extra bogie for additional traction and power. The easily modifiable nature of the A's and the power and reliability of the B's and C's made the locomotive some of the most popular engines on logging railroads all across the US and Canada. But despite Scott fighting for the patent to be in his name, the A's, B's and C's were all commonly known as Climax locomotives. It's noted that even though way more Shay locomotives were sold compared to Climax engines, the gearing and drive mechanisms of the Shays meant they had poorer suspension and often derailed on tracks that the Climaxes could traverse with ease. The Whitmere Steel Company started logging operations in 1912 with a 16-year-old Class B Climax. But as the old engine was showing signs of wear and tear, the company splashed out for a new Shay to help with the work. Not only did the Shay continuously derail, but could only pull half the load the old Climax could. Eventually, the Shay was put to one side and the Climax was pressed back into regular service. Climax Locomotive Works produced just over 1,000 locomotives of all weights and sizes, with the locomotives not only working on logging railroads, but also in mines, plantations, brickyards, short lines, and as shunting engines on heavy freight yards. They even found themselves working in Australia, New Zealand, and many other countries around the world. Unfortunately, the Climax craze couldn't last forever, and by the late 1920s, demand for logging locomotives greatly decreased. Production of locomotives ceased altogether once the company was sold to the General Parts Corporation in 1928. The company continued to make spare parts for the locomotives, but by the end of the 1930s, the factory was sold off and demolished. As steam was replaced by petrol and diesel power, some Climaxes found themselves refitted with internal combustion engines, as their design made it relatively straightforward to swap out the boiler for an engine block. But eventually, most simply vanished along with the logging roads they worked on. Fortunately, a few of these engines have been preserved, and a handful are still in working order. While not the most well-known or numerous logging locomotives, the Climaxes certainly made their mark in railroad history. Their power, reliability, and general ease to repair, combined with their unique design, made them the perfect machines for not just logging, but many industrial applications too. Just goes to show then that sometimes all it takes to get the job done is a good Climax. It's often said by engine crews that steam engines are, to some degree, alive. Whether or not you fully believe that is up to you, but that does raise the question. If some steam engines can be considered alive, does that mean they have personalities? And, by extension, does that mean they can be malicious? Most people would say no, they're just hunks of metal after all, but there is one engine that challenges that theory. In 1925, the Baldwin Locomotive Works produced an 0660 Mallet engine designed for logging work on 3-foot 6-inch gauge rails. Fitted with Walshart's valve gear, a cabbage spark arrestor, and a wood-burning firebox, despite being narrow gauge, it was quite the powerful machine, with a tractive effort of roughly 29,000 pounds. Destined for the Philippines, it operated as part of the Insular Lumber Company, being numbered 7 but mostly referred to as Shay. Shay quickly proved its worth, frequently pulling 32 loaded cars, each weighing around 30 tons, up and down the line, tackling grades of up to 5%. While an exceptional performer, Shay became somewhat infamous among the railwaymen that worked with it, with many regarding it as dangerous. Despite being designed to negotiate tight bends and awkward tracks, Shay was known to frequently derail and break down almost daily. These, combined with the lumber company's likely laid-back approach to safety, often led to serious injury and, in a few cases, death. As much as workers resented the engine, its ability to move heavier loads at higher speeds than the other engines on the line meant it was used often, causing further accidents. And it wasn't just minor bumps and jumping the tracks that cemented Shay's reputation as a death trap. During its career at the lumber company, it was involved in 2 major accidents. The first was caused by a landslide as the result of heavy rains. Shay was travelling down the line one night along a hillside when the earth gave way, resulting in the engine being swept downhill and into the river below. Given how important it was to the railway, the company wasted little time retrieving it, dismantling it where it lay and dragging the pieces back up to the rails where they were taken away and put back together. Years later, on the 2nd of September 1954, Shay would be involved in one of the most fatal rail accidents in the history of the Philippines. The engine was taking a heavy lumber train downhill, with many workers also riding on the wagons when 16 of them broke free and ran out of control. The engine, wagons, and workers all sped down the line and derailed over a wooden trestle, smashing the bridge to pieces. 5 of the wagons fell 100 feet into the ravine below, while the rest derailed. The chains holding the logs broke, throwing passengers off the wagons and crushing anyone and anything in the way as they fell. 82 people lost their lives as a result of the accident. Despite the incident, Shay continued to work for the lumber company for another 20 years, its reputation as a possessed or even cursed engine now practically cemented. Eventually, the lumber company ceased operation around 1976 and began the process of getting rid of its rolling stock. Number 7 was apparently sent to work on a sugarcane railway along with several other logging engines, however was never used due to track issues. As it was no longer of use, talks began of scrapping the engine when it was purchased by Edgar and Sonia Sorosa for preservation. It was cosmetically restored and donated to the local government of Sargai, where it was put on display at Sargai Public Plaza and has remained there ever since. As scary as Number 7 was, there are many who believe that its reputation as a possessed killer wasn't entirely its fault. It's believed that the rails it ran on were rough and poorly maintained, which, combined with its lack of any kind of pilot or guiding wheels, likely caused a lot of its derailing issues. On top of that, pictures of the Shay engines also used on the line show they were poorly maintained, and so it's fair to say that Number 7 was likely poorly maintained itself, which explains why it was notorious for breaking down. All the same, Shete is most certainly an interesting case. Engine men always say that every locomotive has its own personality. Some are quite fierce while others need a more gentle touch. Whether Number 7 was a possessed monster or just a misunderstood machine, I suppose shall remain a mystery. But let's just hope that, if they restore it, it won't cause any further trouble. Since most rails laid for use on logging railways were often uneven and rough to ride on, it was important that the locomotives logging companies used were capable of negotiating them. This resulted in many unconventional articulated locomotive designs, with the most popular being Shays and Climaxes. The issue was the Shays were somewhat shoddy and the Climaxes weren't as great as they were built up to be. What loggers needed was something strong but also smooth running, and thanks to a misaddressed letter, they got it. In 1891, a Mr. Addington of Little Washington, North Carolina, was in need of a locomotive to work on his logging railway, capable of handling grades of 1 in 10 and bends with a 95-foot radius. He wrote to Edward Nichols, president of the Brooks Locomotive Works in New York, to put in an order to be completed within 60 days, but accidentally addressed the letter to the Dunkirk Engineering Company, the confusion likely coming from the fact that Nichols owned both companies. Despite mostly manufacturing hydraulic equipment and specialist machine parts, the Dunkirk Engineering Company also built a few engines of their own. Given Addington only wanted a small 10-ton locomotive, when the inquiry ended up in the hands of the company's mechanical superintendent, Charles L. Heisler, Heisler requested they accept the order, but on the condition that he be given an extra 30 days to come up with a satisfactory design. Addington agreed, and so Heisler set to work. Rather than design a new engine from scratch, it seems he instead set about refining and improving the Class B Gilbert-type locomotives that the Dunkirk Engineering Company already produced. These engines were quite similar to the geared locomotives built by Climax, mostly because the gearing they used was designed by George D. Gilbert, one of the many people who had a hand in developing the Climax design. However, rather than having the cylinders mounted near the front powering a shaft which then connected to the main drive shaft, the cylinders were mounted in the cab in a sort of V-shape pointing downwards, connecting to the drive shaft directly. Heisler altered the Dunkirk Gilbert engines primarily by changing the gearing on the wheels. The old design had the drive shaft power both axles on each bogie directly via a series of gears. Meanwhile, his new design had only one axle receive power from the drive shaft, the other axle being powered by a set of external side rods connected to the driven one. One end of the shaft was also designed to slide a little to help negotiate corners better, with the gears on the bogies being submerged in an oil bath. The gears were positioned just so that they meshed perfectly, required little maintenance, and ran smoothly and noiselessly. Heisler also repositioned the cylinders from inside of the cab to 3/4 of the way along the boiler to help better distribute the locomotive's weight onto its wheels, and each component, from the boiler to the cylinders, was designed so they could be removed easily and individually, making maintenance and replacing parts that much easier. The drive shaft being set between the engine's frames also meant it was better protected from the weather and debris. 2 separate sanding gears were fitted which could be operated either automatically or manually, one towards the front and one towards the rear, which dropped sand before the outermost wheels, ensuring all wheels were sanded regardless of which direction the engine travelled. To keep the rest of the engine cheap and simple, it was fitted with a cylindrical boiler and an internal firebox. With the design complete, the engine was built, tested, and sent to Addington, who responded favourably to this unique design. With other companies showing an interest in the engine, Heisler patented the design and the Dunkirk Engineering Company began to build more of these engines until 1893 when Nichols died. With no place left to build his engines, Heisler was approached by George Burnham, then president of the Baldwin Locomotive Works, who displayed a keen interest in the design. After having his team of technicians report favourably on Heisler's design, Burnham expressed a great interest in manufacturing the locomotive in some of the smaller, private shops he owned around Erie. Heisler agreed, and the Stearns Manufacturing Company began building more of Heisler's engines, even developing a 3-bogie variant until Burnham's death in 1904. Once again without a company to build his engines, Heisler production was put on hold until the design was picked up once more by a Mr. F.F. Kurtze and Roy Swab, and in 1907 the trio founded the Heisler Locomotive Works. During this time, Heisler took the opportunity to refine and improve his machines, making adjustments to the gearing, boosting the engine's overall power, swapping the wooden cabs for steel, and implementing a suggestion of swabs which greatly improved the flexibility of the engine's truck frames. The brakes too were intricate but effective. One small cylinder and one large cylinder was used to provide braking, these being controlled by a 3-way valve. Putting the brakes in the first position, steam would be sent to the small cylinder which applied a moderate amount of braking power. In the second position, the larger cylinder would receive steam, providing much stronger braking, while any steam in the smaller one would be exhausted. Finally, in the third position, both cylinders would fill and the brakes would come hard on, and setting the lever to a neutral position would release the steam and then by extension the brakes. This system ensured that all wheels would be braked evenly, and the settings meant the driver had finer control over the engine's speed when traversing a constant gradient. Aside from the brakes, Heisler wanted to keep the rest of his engine as short and as simple as possible, guaranteeing it'd not only be able to tackle the sharpest bends, but also having less moving parts meant less points of failure, and that his engines could be sold cheaper than other geared engines on the market. Their smooth-running nature, combined with their ease of maintenance and reliability, made Heisler's very popular among many logging railroads, and supposedly were much faster compared to Shay's and Climax's, likely why some ended up being used to pull passenger trains on mountainous roads. Their customizability was also greatly appealing, as not only could the design be modified to burn wood, coal or oil easily, but changing a locomotive's gauge was as simple as swapping out their bogies, and should the engine need to carry more water, a saddle tank could be easily fitted to accommodate. Despite the positive press, the Heislers had one major drawback compared to other geared locomotives on the market, this being their fireboxes. Because the drive shaft ran under the boiler, it greatly limited the maximum size of the firebox. Heisler compensated for this by primarily using Ramsbottom boilers, as the firebox was contained in the boiler shell, but stated the boiler type could be swapped out if desired. This problem, however, didn't seem to dissuade customers, as the Heisler's strength, speed, and ride quality more than made up for its shortcomings. Not only were they used coast to coast in both the US and Canada, but they were even used abroad in booming logging countries like New Zealand. What added to the longevity of Heisler's design was that when internal combustion engines became more affordable, the layout made it very easy to replace the boiler and cylinders with an engine block, allowing companies to upgrade and modify their redundant rolling stock as opposed to just flat out scrapping them. Even with their flexibility and great performance, however, the demand for logging locomotives eventually died down. With the well finally drying up, the Heisler Locomotive Company ceased production in 1941, having produced a total of 625 engines. Funnily enough, the final Heisler to ever be built was constructed 2 years after the company closed in New Zealand in 1943 by A&G Price, with this engine surviving into preservation along with 34 other US-built Heislers. It's tragic really. Despite its seemingly superior performance compared to the Shays and Climaxes, the Heisler, being the last of the trio to be developed, combined with its on and off production, left it lagging behind in terms of numbers built. All the same, the fact that Heisler managed to cement his design as a staple of logging railroads long after so many other geared locomotives had flooded the market just goes to show that even if you're late to the party, you can still leave a big impression. Steam locomotives have been saved from scrap throughout the years in many different ways. Some were donated to museums and preservation societies immediately after being withdrawn from service, some were purchased from scrapyards before they could be dismantled, and others were hidden in the backs of sheds or out-of-the-way sidings so as to keep them safe while efforts were made to save them. For many engines, it was simply a case of being in the right place at the right time. But one locomotive, however, managed to avoid the cutter's torch in a unique way, by crashing. Built in 1909, number 126 was a custom locomotive ordered from the Baldwin Locomotive Works by the Little River Railroad in Tennessee. The railroad needed a powerful engine that was not only lightweight, but also able to negotiate extremely tight bends. As such, a Mallet wheel arrangement was chosen, giving the engine the rare wheel layout of 2442. It was the first engine of its kind and the first Mallet engine Baldwin ever built, fitted with 4-foot driving wheels, high and low pressure cylinders, Walschaerts valve gear, and initially running on coal before being modified to burn oil shortly before it was delivered. Little River Railroad took delivery of the new engine and were very pleased with it. For about 5 minutes. Despite being able to negotiate curves as tight as 160 feet and having a relatively light axle load, number 126 was too heavy for the railroad and often derailed on bends. After less than a month of use, the Little River Railroad sent it back to Baldwin and requested a smaller engine. Baldwin built another 2442 for the Little River Railroad which met their needs, leaving them stuck with 126. They put the engine up for sale and just under a year later it was purchased for use on the Columbia Riverbelt Line Railway in Blindslow, Oregon. Rather than numbers, the railroad gave their engines names, and so 126 was officially named Skookum, a Chinook jargon word meaning strong, powerful, reliable, or brave. The name seemed to be fitting, as the engine proved to not only be strong, but reliable too. It became a frequent sight on the line, and by 1911, countless local papers were reporting on and singing the praises of Skookum. The positive press led to Baldwin receiving well over 50 orders for logging engines from various railroads. While not quite able to traverse bumpy and poorly laid rails like Shays, Climaxes, and other logging engines, Skookum was more powerful than them to make up for it. Able to bring similar speeds and tractive effort as other conventional locomotives on lines that conventional engines otherwise wouldn't be able to run on. Even as newer, more refined logging engines came to market, Skookum was still light enough and powerful enough to keep working. In 1920, it was sold on to the Carlisle Pennell Lumber Company in Onalaska, Washington, where it was numbered 7, a number it kept for the rest of its working life. In 1924, it was transferred to New Orcombe Valley Railroad, leased to the Mud Bay Logging Company in 1930, worked for the Carlisle Lumber Company in 1931, before ending up in the hands of the Deep River Logging Company in 1933. It's at Deep River Skookum worked the longest as their primary locomotive, working the line frequently for 22 years and seeing plenty of action when in service. There's only so many trees you can cut down, however, and by 1955, Deep River was slowly discontinuing logging operations as the demand for lumber decreased. By February, it was just number 7 and an Alco 262 working the line, with the plan being to scrap both engines, the rails, and the remaining rolling stock at the end of the year. Despite being a unique and exceptionally performing engine, it seems nobody was interested in preserving number 7. Fate, however, had other plans. On the 23rd of February 1955, number 7 was running tender first, pulling a load of empty cars when it ran over a broken rail on a short trestle and derailed. It awkwardly tilted to one side but remained somewhat upright. The crew inspected the engine and felt it would be safe to leave it where it was. As it was already afternoon, the fireman dropped the fire and the crew went home, planning on re-railing number 7 in the morning. The fireman also decided to fill up the boiler just enough to cover the firebox crown sheet so they could light the fire once the engine was re-railed and put it straight back to work. This, however, was a mistake. The additional water shifted the engine's balance, causing it to topple off the line and onto the engine's side. Luckily, it didn't fall far and the ground was very soft, meaning number 7 had suffered minimal damage, but it would take a significant amount of time and effort to get the engine back on the rails. Given the logging company was going to end operations in a few months anyway, the decision was made to just abandon number 7 where it was and run the line using just the 262. When it came time to scrap the line, number 7 was found to be too remote and too awkward to cut up, and so rather than try to salvage it, the railroad just pulled up the track and left it in the middle of the woods. There, the engine would remain for several years. Despite the line being gone, the engine wasn't forgotten. In 1956, not long after the line closed, a rail fan by the name of Charlie Morrow looked to purchase number 7 and get it running again, feeling such a unique and innovative engine deserved preservation. He managed to buy it at scrap value for $1,200 and formed a group to help restore the engine, but there was still the issue of actually moving the thing. The line was pulled up and no roads were near the site, and so it would be a monumental task to get the engine out of the woods. In the summer of 1960, Morrow and his colleagues set about dismantling the engine and taking it to their workshop piece by piece. Not only was the engine starting to rust from being exposed to the elements for so long, but the boiler hadn't been removed from the frame since it was built in 1909. The bolts were so worn and rusty that the team had to resort to blasting them with dynamite to separate them. The parts were eventually moved to Snoqualmie and left in Nilbok Yard where plans were made to restore and rebuild the engine, but these fell through. Number 7 remained in pieces for many more years, passing from owner to owner as attempts were made to get the engine into some kind of working order. Finally, in 2004, it was moved to the Oregon Coast Scenic Railroad where work on reassembling the engine properly began. It took a long time, but finally in 2018, number 7 was steamed for the first time in its Columbia Riverbelt Line livery with its name proudly painted on its cab. After resolving some teething troubles, Skookum made its first official run in March 2019 and has since been running along the Niles Canyon Railway in California. Skookum's story is certainly a unique one. Not only did the engine earn its name, proving to be both powerful and reliable while in service, but also managed to evade the cutter's torch in an unusual way. Most engines that can't be re-railed are simply cut up where they lie, but Skookum was fortunate enough to derail in the perfect place to avoid that fate. Call it what you want. Maybe Skookum got away thanks to laziness on the railroad's behalf, or maybe it was just being in the right place at the right time. Whatever you believe, let the story be a reminder that just because you're off the rails doesn't mean you're at the end of the line. Subscribe for more.